mainly GenAI side on the cloud. We talked about the code generation tool, GenAI Solution. Then we moved with the RAG implementation. What is RAG? As the current business is moving towards RAG for a specific skill set. So how I can differentiate with traditional LLM and how to implement it, right? We talked about. So this is our main focus. So let's move with that. But before moving with this content, first let us talk about what we have done last day. So let's start with this. Let's talk about what we have done last day first, and then we'll move with our today's content. If you see last day, we talked about how GenAI work and its internal architecture, where we talked about that the complete implementation will start with the natural language processing. Whatever the input will come inside your prompt as a prompt. Each and every words in your sentence will be represented as a feature vector, and our LLM will take the input as a feature vector. So then we talked about that your input will move inside our transform architecture. Transform architecture contain encoding and decoding. So your input will first go through the encoding, then it will pass to the decoding, then it will go with our generative pre-trained transformer model, and we'll get the output. So if you remember, last we talked about that before we come to transformer model, we find the initial stage recurrent neural network, RNN. Recurrent neural network is used to predict the next word, but it has some limitation. That is, it is very inefficient when the gap between relevant information is very large, as well as it cannot prioritize task. So this problem is resolved with another one deep learning model that is called LSTM, long short-term memory. So LSTM can selectively remember or forget things that are important and that are not so important. So it can prioritize the task. One problem resolved with the LSTM, but the same things when sentences are too long, LSTMs are not successful. Then we find the attention model. Attention model pay attention to specific words, and attention can be thought of as a mechanism where different inputs, you're going to get the different outputs, and attention model can give attentions in between multiple words. We find self-attention model, where you find different words in the input sequence and learn to focus on most relevant words for each position. So then you find the transformer model that parallelism is resolved with the help of transformer with using encoder and decoder. And the complete overview we'll find like this, how a LLM architecture look like for ChatGPT. Right. So next we moved our discussions with hallucinations. That is, if the model is not properly trained, you'll not get the output right properly, right? So that is said to be as an hallucinations. We talked about different types of model like text to text, text to image, text to what, video, text to 3D, or task to task. So, so this LLM or LMM together we defined as a foundation model, right? And that model is being trained with huge amount of data in billions of parameter. Then we moved with generative AI from different cloud. Azure OpenAI from Microsoft Azure, AWS Bedrock from AWS, and Vertex AI and Gemini from GCP. Last day, if you remember, we talked about generative AI from GCP. That is provided by a solution called Vertex AI. We talked about a code generation model. Today we'll move in depth on them. like AWS Code Whisperer and GitHub Copilot. We talked about some popular tools that is used throughout the world, some popular GenAI tools that is available in the market. We moved with ChatGPT. We've seen that how we can use prompt using ChatGPT. We talked about the difference between ChatGPT and GenAI. So both are deep learning models. So GenAI, right? So next we move towards prompt engineering. So what we say is that we can write a prompt that can be a good prompt, that can be a bad prompt. So how to write a good prompt? Good prompt should have context, task, instruction, and data. And you can remember we've given on examples of good prompt, how I can write a good prompt that have context, task, instruction, and data. Then we moved our discussion with generative AI using cloud. And last day, if you remember, we talked about LLM using GCP. So as we have done, ChatGPT is one type of LLM, then OpenAI product. Same like that, we have multiple LLMs from GCP. So we talked about this diagram. You can see here different types of LLM and LMM from GCP like Palm, Lambda, Calm, Bird. So current foundation model that we find from GCP, its name is Gemini. In the year 2024, it is defined as Gemini. So we have worked on Gemini last day. If you remember, we have done some examples last day using Gemini, like we find image to text LLM, we find video to text LLM, right? We find so like this way some LLMs we have executed as it is given in our GCP, right? And we've given some hands-on also, possibly have completed those hands-on. So let's move to the next step. So today our main focus will be on LLM using AWS, right? So how we can use a prompt, that means LLM and LMM with AWS. So if you remember last day, we talked about that the GenAI solution from GCP is Vertex AI Studio. Means in that platform, you'll find all the LLMs of GCP. Same like that, AWS has a particular service that is called AWS Bedrock. All the services will be inside AWS Bedrock. All LMs and LMMs are under AWS Bedrock. Right? So let's understand this AWS Bedrock, right? So you can see here Amazon Bedrock is a fully managed service that offer a choice of high-performing foundation models from leading AI companies like AI21 Labs, Anthropic, Cohere, Meta, Stability AI, and Amazon via single API. Along with a broad set of capabilities you need to build GenAI applications. But if you remember last day when you're talking about GCP GenAI solutions, you can use the LLMs and you don't need any approvals to use the LLMs in GCP. Whereas in case of AWS, you need approval for some of the LLM or LMM access, though they have given some default access to some basic LLMs. Let's understand AWS Amazon Bedrock platform. We say Amazon Bedrock as a service. In that service, we have multiple LLMs and LMM. So let's explore that, right? So to explore, what we have to do is that we have to log in inside AWS Cloud. We should have an AWS Cloud account. If you have already an AWS Cloud account, you can use that one. Else, you can create an AWS Cloud account and the email ID that you will use That should be a root user email ID, and you should have a password, right? You'll get a password once you will do the registration. Same like that in case of GCP, right? You have to validate your credentials with a credit card. Same like that, if I'm going to create an AWS account, you have to validate your credentials with a credit card. Right, that is one scenario. Some for whom it is already there, it's fine. For whom it is not there, if you're doing it first time, you can do this, right? Uh, right, fine. So here our focus is how to, this part will come in the next step. Let's first understand AWS Bedrock. Bedrock, I came inside my AWS account, right? And you can see all the different services inside AWS, right? So what I have to do, just write here AWS Bedrock. Just write here AWS Bedrock. You can see here Amazon AWS Bedrock, right? So just go inside this. If you see here that the easiest way to build and scale generative applications with foundation models. Here you'll find some of the benefits and different types of model like chatbot, text generation, text summarization, image generation, right? Like different types of model examples that have been given, you can use. These are some of the models, Cloud, Command, Stable Diffusion, Amazon Titan, Llama 2. So you can see here some of the foundation models under AWS Bedrock, right? Now let's start with this, how to use this model. So get started. Now here in the left side, you'll find different foundation models are there. We define them base models like Cloud version v2.1, v2, right? Next, you'll find Titan, embedding G1, Titan text G1, right? So you can see these are the base models from AWS that support LLM and LMM, right? Now the question is that each and every model, they've given some introduction, you can see here. They're used for text generation, conversion, multiple reasoning analysis, text generation, conversion, multiple reasoning analysis, text generation, conversion. These models, they've given something, right? Embed, translate text into numeric vector that models can understand. Embedded translate text into numeric vector that models can understand. Now here Titan they have given. So here Titan foundation models are family of models built by AWS that are pre-trained with large datasets, can be powerful and general purpose model. Right, like this way you can see the models are there, right? Now the question is that how to use a model. As we have used ChatGPT in OpenAI, as we have used some models, LLMs in GCP under Vertex AI Studio. Same like that, I have to want to use a particular model. Now see here, if I want to use a model, just select here in the left side chat. Here I'm just selecting left side chat. Now when I'm going to do this chat, I have to use one model from AWS. So select that model, which model you want to use. Now you can see Anthropic is there. Under Anthropic, you have these models. Claude 2, Claude 2. So these are the models. All are LLMs, foundation models under GCP. Similarly, you have under Amazon, you have Titan, Text G1 Express. Now see here that they are the model providers. Okay. Now I want to use a particular model, right? So you can see which model you want to use. As you might just select Titan on demand apply. So you can see here, you're going to use this, right? But you know, if you go inside base model, okay, it's okay. You can select a particular model. I'm using Titan on demand, apply. We can use Anthropic. Now you can see here, just see here, request access. For Amazon Titan on demand, just click apply. You can use it directly. Whereas Anthropic is saying it is request access. If you click request access, you can see here, just see here that from AWS, okay, this two model, Titan embedding G1 text, Titan text G1 Express, only this two model is given access by default, right? Just see here. But for other models under Anthropic provider, this two model access you don't have. They're saying that use case details required. Same like Cohere, available to request. So you can see these two category of provider models, you don't have access. When they will give approval, then only you can access them. By default, you have access to these two models only, these two LLMs, right? If you click here, manage model access, they will tell you that if you want to access these models, submit use case details, right? They're coming with some conditions, something like that, right? It's okay. We are going with this model access, Titan one that they have given access. It is same like with ChatGPT only. Select the model, Amazon Titan G1, apply. Right now here, I'm going to write something, some text. Write something. Describe cyber war. Azure. So just write. Based on your input, you can see it is using. It has given a response here. Based on your input, it is given some response. Yes. So this is the prompt that you have submitted. You got the output from this model, right? And in the right side, you can see the temperature. So here you have used this model. Output token is this much. Cost is this much. Overall summary, right? So this is one model that they have given. So it is, if you see here, it is same like look like your ChatGPT only, conversational based from OpenAI. That means if you know how to use an LLMs in one vendor, you can use the LLMs for many other vendors also, right? To some extent, same, right? So same like that. If you go for text, okay, and select a particular model, I'm using this one only because we have been given by default this access. And if you're going to write a prompt, write the prompt. Something like that. Let me check if it's coming with some answer. I do not get instruction. Okay, it's fine. So just write something. Describe. Just write. Let me check. So it doesn't have any instruction as such. So they are saying that we have different experience. Okay, challenge. It's okay. So you write based on this requirement. So it is coming to some extent, right? When I'm writing here, describe live. It's coming with some answer. They're coming with some answer. It is not that they're not coming. It is coming with some answer based on your input prompt. right? Yes, the model is working, right? But same like ChatGPT only. Now you'll say that if I want, this is an examples of LLM, right? But if I want to work on LMM, means based on the text, I want to generate some image, video, audio, right? So we don't have access to them. If you want to have access, you have to request access. Once they'll approve, then you can use it. This is, that is the limitations is still now, Amazon Bedrock, they're exploring their GenAI models. Right. So still now it is on exploration stage. And to go for LLMs, you need an approval to access those base models. Then you can use them. Right. Okay. So that is from code. And the code generation tool from AWS is AWS Code Whisper. It is one type of revolution today. AWS Code Whisper. Right? Just, you don't have to write the code, just write what type of code you want, based on your input as a prompt. It is going to generate the code. Just see here. So if I want to use AWS Code Whisper, we should go with a standard library, standard IDE. One of the popular standard IDE, as you know, Visual Studio Code. You have to download that Visual Studio Code from this link. Okay. Once it is done, then the second option is that you have to install the latest versions of AWS Toolkit. Okay, we need this toolkit to add as an extension inside my IDE, right? So once this first step is done, what you can do, just see Control V. You can just see here. You can download Visual Studio Code from this link. You can download this one for Windows. Once download and you have installed it, and from here you have to download the AWS extension, AWS Toolkit for Visual Studio. Okay, just we have to click here, AWS Toolkit for Visual Studio, and you have to download that. And you have to click download. All right, so once it is done, right, now what I'm going to do in the ID, in the left side, you can see the option called extension. Go inside that extension and right here, AWS Toolkit. Just select AWS Toolkit. Since I have already installed it, the setup I have already done it, because sometimes it will take some time to create the setup and most of the time is spent there only. That's why you have already created, already installed this AWS Toolkit. That's why it is coming uninstall. If you're doing it first time, for you, you'll find the option install. Just install it. That's it, right? AWS extension setup with the ID with our AWS account. So in that step, in this example, already I have done this. AWS Builder ID created and it is connected with our AWS account. This is the AWS Code Whisper. So the setup is ready with us, right? Now what we're going to do is that just I want to show you that how it is going to generate the code using AWS Code Whisper. It is very, very good and very excellent. If you are a actual coder, then you'll find an excellent module. It's one type of revolution. I just now I'll show you here. Just see here. I'm going to create a class. I just want to create a class. Just create a particular class here inside the same location and use the class name as employee.java. It's a simple Java class, right? Now, how to give the prompt? Just see here in case of Java class, I'm giving the example for Java that write an employee class with instance variable called empid, emp name, and emp cell. Let's see what it is saying. Let's see here. Now see here, see AWS code is generating. Right? If you want to use it, it's fine. If you don't want to use it, write enter. Just write enter. It is saying, see, if you want to accept that particular line that is created by AWS Code Whisper, just write tab. Enter. If you want to accept that particular line that is created by AWS Code Whisper, just write tab. It will accept it, right? Fine. Enter. See, it is generating some code. Display method. If you're fine with the code and you want to accept this code, click tab. Accept it. Then just see here, it is generating some main methods. If you want to generate the code, if you don't want, just write enter. It will not be accepted. If you want, no, I just write enter. You find some generated code. If you want this, just write tab. Just see in a fraction of a second, you don't write a code at all. Basic code Java code is ready. Simple class. Yes, we have some more. So let's see, assume you're creating a simple SpringBoot project, microservice project. You're creating, and your generative AI setup is fine. See here, it's fine. GenAI setup with your existing IDE. Now, how I can generate the code for a microservice? Just I'm taking an higher example. So as you know, some of you who knows it, that if you create a microservice in a Springboot that have these layers, controller layer, DTO layer, entity layer, exception layer, mapper layer, repository layer, service layer. You have multiple layers, right? So let's create a controller in case of a particular microservice project, right? So if I want to create a controller, let's see, my controller name is order controller, something like that, right? So create a controller, order controller.java. So I'm creating a controller inside of my microservice project. So I want GenAI to create the corresponding code. So how to create? So you can just, I'm not writing it here, just copying from somewhere like this. Let's see. I'm writing here, Control V, create order controller, create, this is the prompt, order controller with validation, with create, read, update, and delete capabilities. So this is my prompt. Now let me check if Code Whisper is going to generate the code or not. Enter. Let's see here. It is saying REST controller. Use tab if you want to accept the code. Order controller, right? Here it's a method for creating an order, right? Post. It is using post method type. So controller should call service layer. That's why the service layer also gets generated. All right. Okay. If you want to use your tab, enter. Let's see. So if you see here, this is the implementation for get. This is the implementation for post. Right now, see, code is generating the code, and this is an implementation for put. Put means if you want to do update, right? So then you can see Gen AI is going to generate the code. Control S, tab, enter, tab. Right, so you can see here, we can do all the operations: insert, update, delete, select. Right, create, update, delete, and select. Right, we can do all the operations. Right, so this is a structure of your controller. If you want to do some, now you can see all the values are same. You have to change that value based on your requirement. Right, you have to do the customization. But this is not fully standard because they have not given any validation type capabilities. All right. So you have to explore that one. Right? This is the controller, how I can generate a controller. Same like that, in case of microservice project, I want to generate an entity. Right, I want to generate a entity name, its name is shipping, Azure. So create an entity called shipping.java. Right, so in shipping.java, what you're going to do is like, I want to create an entity for our Spring Boot project, right? So create a Spring Boot entity. You can write the prompt, right? Like create a Spring Boot entity, right? A Spring Boot JPA entity for shipping. Let me check what is generating. Okay, enter. So we can see it is giving package. You can see here it is coming with the complete structure of your JP entities, how you are going to. Now see here, this is an Spring Boot JPA entities, right? That is coming with shipping ID, shipping address, shipping city, and shipping state. And you can see here, this is the constructor. These are the instance variables. Right, so like this way, you can generate the code, right? Complete entity generated. You don't have to write a single line of code, right? We don't have to write a single line of code, right? Same like that, if you want to create, let's say I want to create the repository layer. Okay, so repository layer, if you want to create, just write shipping repository shipping repository.java, right? So in shipping repository.java, I want to create a repository layer. So what should the instruction? Just provide some instruction, same like that you have used earlier. Repository class for shipping with these methods, these variables. Let me just check. I'm just copying the prompt. Repository class for shipping. Repository class for shipping with method find by shipping ID. Find by shipping ID. Find by shipping name. Find by shipping name, something like that. You want these methods should be there inside the repository layer. Already you know, right, how to create a repository layer. That is your it should be an interface and it should override. I mean, it should from the API method, right? It should override JPA repository or CRUD repository, right? So that you can use a predefined functionality of these interfaces inside your repository. Plus, I need some other methods also that I have just mentioned it here. Let me check if it is going to create that repository class or not. If you write enter, just see here, Control S. So you can see here, code whisper is generating code for the repository layer. You can try, everyone can try this if your setup is ready. That's it. This is your shipping repository for a Spring Boot project, right? Shipping repository for a Spring Boot project, right? Okay. Now the next one is Control S. You can try the next one. Next one is called service layer. If you want to create the service layer or implementation layer, same like that, you have to provide some instruction as a prompt. It is going to create that service layer, right? Same like as we have done it for entity repository, right? So this is how we do it. You know, we generate the code with the help of AWS Code Whisper. An excellent tool to generate the code, right? You can try that one, not only for Spring Boot project. If you want to go for UI side, you know, you can same generate the code for your React also, right? If you create a React project for your React project also, you can generate the code. Right, fine. So let's move to the LLM using Azure. Still now we are talking about LLM using GCP, Gen AI implementation using AWS. Now we're moving with Gen AI implementation using Azure. So the Gen AI solution from Azure, it is called Azure OpenAI. We have multiple services in Azure. The actual solution is Azure OpenAI. So Azure OpenAI service provides a safe and reliable way to access cutting-edge language AI models like OpenAI ChatGPT, Codex, and DALL-E in Azure ecosystem while safeguarding the customer data. So this Azure OpenAI is not the OpenAI as you find in ChatGPT. There is a difference between OpenAI and Azure OpenAI. Azure OpenAI is the LLM or Gen AI solution from Azure, right? In combinations with both the organization OpenAI and Microsoft, right? So that we try to explore here, right? Right. As we have from GCP, Vertex AI Studio, as we have from AWS, AWS Beanstalk, same like that. Same like that from Azure, we have Azure OpenAI, a platform that have multiple models, right? Now here, if I want to access this Azure OpenAI, I should have an Azure account, same like that, AWS and GCP, right? And let's move with this Azure. and RAG++. Let's see whatever things we talked about still now. GenAI, OpenAI, GenAI solution from OpenAI, that is ChatGPT. We talked about generative AI solution, that is a GenAI solution from different cloud like AWS, Azure, and Google Cloud, right? Now, this Gen AI, that is LLM or LMM that we are going to use, industry cannot use them directly. That traditional LLM have some limitations. Whatever the LLMs created by the clouds, whatever the LLMs created by OpenAI that you find in the market, they have some limitations. And that limitations is resolved with the help of RAG. RAG that you find here, that is RAG plus, full name is Retrieval Augmented Generation or RAG plus. Now we should know what is this RAG. First of all, what is the problem with traditional LLM or LMM? That you should know first. Then we should know how RAGs resolve this problem and why industry is moving with RAGs. How industry is moving with RAGs. Those things we try to explore here. Right? So if I want to say RAGs, it is a powerful NLP technique for enterprise search application. So it's a new approach to NLP that combine the power of LLM with a precision of information retrieval system. Now, let's talk about, when I'm going to talk about it, let's talk about it very simple way. What is the problem with the traditional LLM? That's why we need RAG. If you remember last day, we talked about one example. Let me just open this ChatGPT once again. This ChatGPT's URL we have used last day, right? So let's open the ChatGPT once again. Let me just talk about ChatGPT is one type of LLM. And this LLM have some limitation. Let me just show you the limitation here. You open this, Control V, enter. Let me just check it's working or not. I've shown you last day also. The ChatGPT that you are using, it has some limitation. As for example, this ChatGPT 3.5, it is trained with billions of parameters till September 2021. So the value it is, the data or billions of parameters that is being used to train this model till September 2021, right? Now, if I'm just writing some question, just see here. I'm writing here like who will win the war between, let's not go inside this. Let's talk about some other question like what is the price of stock of Infosys, right? Or Wipro in Indian stock market, right? Let me just check. See what it is saying. It's saying that I cannot provide real-time information like stock prices in ChatGPT of OpenAI. Remember the same questions we have given last day in GCP LLM, right? But the GCP LLM, what it is saying is that the GCP LLM that they're giving some data, but that data is 3 years old. So the thing is that the LLMs don't have real-time access. This is one of the major limitations of LLMs in any specific field. And that is the limitation that is resolved with this RAGs that we are talking about here. So what is this RAG? It's a technique that combines the capabilities of pre-trained large language models with external data sources. So pre-trained large language models we have, and to get real-time access of data, we are going to integrate it with some external data source so that we can have access to real-time data. Right? So that, so what RAG is, if I want to say what RAG is doing, so RAG is a new approach to natural language processing that combine the power of large language model, with the precision of information retrieval system. Now here, RAG models are trained on massive data set of text and code. They may even leverage existing models, general LLMs like Google Bird, ChatGPT. Now the point is that what is the limitations of traditional LLM? Let's understand using the internal architecture of traditional LLMs. So first we'll talk about what is the limitations of traditional LLMs. Let's write it using this diagram. Let me just show you using this diagram. Here in the left, first I'm talking about, let me just put it like this. Or if you want, we can go with this, I think it'll be better. .com. And you can just write here what type of diagram we want. We want to create a diagram for RAG. Gen AI. Let's say like this, create. Let's understand the difference between the traditional LLMs and the RAG implementation. Then the complete picture you will get. What is RAG? Why industry is moving towards it? Right. So first we're talking about here. We'll talk about traditional LLM. Traditional LLM. Internal architecture. Traditional LLM internal architecture. Right. So let's see how it works. So assume right here in the left side, people. So let's take an user. This is an user, and this user send a request, okay, to the LLM framework. So assume the LLM framework is like this. You can use a particular structure to define LLM framework here. So assume this is the LLM framework. Okay. So this user have requested to this LLM framework. If you want to write some text. LLM framework, right? Now, user have sent a request to this LLM framework. It has thrown some question, something like that. So assume these are the questions that came to this LLM framework. So what it is saying is that, or you can say that the user submits a question or query to this LLM, right? So now what it will do is that this will go towards from the LLM framework. It will go towards this LLMs. So we just write here LMM, and this is the same things. It will go from LLM framework to LLM. So here you can say like the LLM framework formulate a prompt that is submitted by the user, right? With the right context and submit it to this LLM. Now this LLM then perform a semantic search on its vector database. So assume this is the vector database. Okay, I'm just writing the text like this. Vector database. Vector database is one type of mathematical, lots of mathematical operations that being used inside the vector database. Now, what you're saying is that this LLM is going to, this LLM is moving to this vector database. Okay, so you can say like this, that the LLM search for documents in the database that are semantically similar to the prompt that is coming from the user, right? Then this vector database is going to return. It is going to return. I can write like this. It is going to return the context result after search to the LLM, which sends a raw response or answer back to this LLM framework. So we can write it like this, right? And this LLM framework format that response and send it back to the customer or the client who have sent that particular prompt. This is how it works in case of traditional LLM internal architecture. Now the question is that, you know, these LLMs are like one type of black box. That means, you know, they only knows what they have been trained on. If you see, just now we have given some question, right? Please share me the stock price for Wipro or Infosys or Atos or Evidian. There is no answer because they are trained on with the data with some past data. Examples like ChatGPT 3.5 is trained on the data till 2021. So they don't, source their answer. There is no source. But the answer that is connected with some real life update. And they may make up answer into the hallucinations we talked about, right? So they cannot answer questions using knowledge outside of their training data. That is the problem or limitations with this traditional LLMs. LLMs created by OpenAI, LLMs created by any cloud. That is the problem. Because when any cloud will create the LLMs, they're going to train the data till that particular date, right? After that. So that is the problem, right? So to resolve this problem, customer want real-time data, not only real-time data, but also specific data is in a specific field or a specific work area. A specific field like is like in the medical domain, a specific field like social media, a specific field like trading industry, a specific field like uh, travel and tourism. So like that, right? So that's why RAG come into picture. And in this RAG, what we talked about is that in the RAG model, LM is first used to interpret the meaning and intent of the query. Then LMs are instructed to retrieve related content from one or more specific content store. So let's understand how a RAG model work. Let's see how this RAG model work. So let me come into the same picture and let's talk about how RAG model work. So here I'm just writing here RAG architecture model. RAG architecture model. Right now in this RAG architecture model, same like that. Let me just talk about. Let me just find here. Search one person. You select one person here. Okay, so this is the person, right? Now, what it is doing is that in case of RAGs, is going to send some request. Okay, so you can send a request, and that request is going into the LLM framework based on the user query. So assume this is your LLM framework. And here inside this LLM framework, we're going to write some text like LLM framework. Right now, when the input came inside this LLM framework, so what we say that the user submits a questions or query inside the LLM framework. Right. So next what will happen is that RAG framework performs a semantic search inside a vector database containing some specific data source. So what happened here is that this LLM framework, in case of RAG, how it works? This LLM framework will search the details inside a vector database. So assume this is a vector database. Or this is a vector database, okay. So assume this is a vector database. And let me just write vector database. So this LLM framework will search the input inside this vector database, assume. Right? So, and it is going to send the response. Response will go from vector database to your LLM framework. So what you're talking about here is that in case of RAG, what will happen? RAG framework performs a semantic search of the vector database that contains some embedding forms. Now here, whatever the results will come from the vector database, these are returned and submitted as a prompt to this LLMs. All right. So here, what will happen is that this vector, in case of RAG implementation, this vector database is connected with some content. So let's see. This is a content. So this is content. Assume this is general. I'm just going to write here different some file types approach. Assume files. Let me check if it is coming or not. Okay, so assume I'm just copying here. See here, these are the files, right? So our vector database, in case of RAG implementation, our vector database is connected with this type of external sources. This type of external sources. Our vector database. You can define this also. Right now the response will come from this external sources, right? So what you can say here is that the whatever the results, vector database is going to get it from the external sources. The context results are written back and submitted as a prompt to your LLMs. Okay, so here it will be submitted as a prompt to your LLMs. So assume your LLMs is this. LLMs, right? So which speed reads. Now the LLM response is then processed and sent it back to the LLM framework. So its response will come from the LLMs to the LLM framework, which formulates a response to the user, right? So you can see here which formulated response to the user, like this. Right. So in RAG model, the response is also likely to provide a link to some or all the related source documents for the answers. Okay, so similar to what that keyword search application provide, right? So what you find inside this RAG implementation is that the RAG model works by first using LLM to understand the query. Then the LLM use the understanding to retrieve relevant information from the database. The LLM then generate a response based on the retrieved information and send the answer back to the user, right? So that may have some other external links also. This is how the RAGs will work. So the external content that may be connected with some real-time data source, right? So that the problem of real-time data access, that you find the limitation of traditional LLM, that is resolved when you have some third-party access to some real-time data, and that is resolved with the help of RAG. Right, and most of the time this RAG implementation we implement using some of the component called LangChain. Now you will find another one. You will find another one implementation that is called RAG plus. Control Z, RAG plus. So what is this RAG plus? Let me just talk about here only. You'll find another one implementation that is called RAG plus architecture model. RAG plus architecture. So the question is that what is this RAG plus architectural model? How it works? Right. So in case of RAG plus architectural model, let me just copy the same things. In case of RAG plus architectural model, let me just see what is the changes here. Is that the user asks for a particular query, right? The system determines, in case of RAG plus architectural model, the system determines if the query is a simple search or complex search. So here is the change. How it is, let me just tell you. Assume in case of RAG plus implementation, assume Control Z. So it is going here and it is going here. In case of RAG plus, what will happen? When users has entered some input. Here, assume we want to use some symbol like a question mark type like that. Type of question mark type here. Let me just write this symbol here. The moment user sent that response, user sent a questions. Okay. Now here, what will happen is that it is going to cross check if the question is simple or complex. So I'm just using this symbol here just to make it Control Z. So you can see here, Control Z. So in case of RAG plus model, when the input is coming from the user, it is going to cross check whether the question is simple or complex. Right, that's the first point. If it find if the query is simple keyword search, then it is going to send the request to your LLM framework. It is like that. So here one type of condition is being checked. What type of query it is simple, you can send it to LLM framework. Then LLM framework with the help of vector database, it's going to give the response back to the user. This is now if the question is complex. If the question is complex, then what it will do is that it is going to send. Send the questions like this. You can say it is going to send the request to. It is going to send the request if it is complex. It is going to send. It is going to send for a semantic search inside a vector database, something like that. So assume we have. It can apply some semantic search in. Assume this is one type of another one vector database. It applies something in vector database, and from here it is going to connect. This is also a vector database. It is going to connect. Assume it is like this. I'm just writing. It is going to connect some external files and those external files are nothing but the source. So in case of RAG plus model, what it will do is that the user asks for questions and queries. The semantic search, if the query is simple, then it will go to the LLM framework and it will get the output. If the complex is, it is not simple complex, it will go to the vector database, and vector database connected with some external file systems or sources, right? So the system search for documents in the database that are semantically similar to a query. Then system then send that semantic search result to the LLMs to generate the corresponding response. So this is how the RAG implementation work, or RAG plus implementation work. We implement this RAG implementation using, you may have heard the name. Its name is LangChain. Generally, do the implementation using LangChain. Now the question is that yes, how you can differentiate this approach with the traditional LLMs? It is going to resolve lots of problems. You will get improved accuracy. Real-time data access will be successful for a specific field because you are going to connect the data source for a specific field, right? And it will include improved security, increased domain expertise, because this RAG implementation comes with your LLMs. You're going to integrate some specific fields. You're going for RAGs for uh, medical industry, or going for RAG for trading industry or e-commerce industry, right? Like this way, right? And it will give us one type of advanced auditability. RAG models can track from which source they use to generate each response. Okay, so the question is that where the industry is using these RAG models. Industry using these RAG models in your scientific and research uh, uh, applications, or customer chatbot related to scientific research application, technical support applications, right? Knowledge management tools or content generation tools, right? We use there, right? So this RAG model solves a number of important challenges in case of search, like knowledge security. Means RAG models can be used to ensure that the information presented accurately and reliably, and only to authorize the users. Then yes, so for this RAG implementation, it is going to prevent hallucinations, right? RAG models can be used to prevent LLMs from generating inaccurate or misleading informations, right? These are some of the advantages. That's why, RAGs is much more accepted today, right? So, right. So these are the things that we should explore, right? That we talked about in this. I've just given one diagram, but I think this is the better diagram to talk about using this, right? So this is our traditional approach, how traditional LLMs architecture work, and this is the RAG implementation, how it works, right? So the other topic that we should cover in our curriculum, right? So I'll right, that we have done, right? So now you can see here where we are from day one itself. We started our discussion with AIML introduction. Then we have moved with deep learning introduction side. Theoretically, we talked about GenAI introduction. We moved with ChatGPT and prompt engineering. We have touched some of the things. Then we talked about how I can implement GenAI with cloud. You move to Gen internal architecture as well as you move towards the RAG side. So the next level that come into picture, some in depth, like how we can, if you want to create our own LLMs, how I can do that. What we are doing is that we are using the LLMs created by some vendor, created by AWS, created by Azure, created by Google, right? Or created by OpenAI. We are using those LLMs, right? If I want to create our own LLMs, how I can do that, right? So as a core developer, that is one scenario. Another scenario is that how to use an LLM for a specific area of business using prompt engineering. I can use it in entertainment business, how I can use it in sales and marketing side, how I can use it in a specific area like social media applications, or you can say into some other industry, right? In medical industry or trading industry, right? How I can use this LLMs in a specific business area, right? So that is, that in the next level.